Hey guys, in this video I will discuss the intermediate value theorem and walk through an example to show how it can be applied. So the intermediate value theorem applies to continuous functions. Let's say we have a function f of x that's continuous in the interval from a to b. This theorem says that for any number n between f of a and f of b, there must be some value c between a and b where f of c equals n. So looking at the graph, let's look at f of a and f of b. This theorem says that for any value between f of a and f of b, there must be a point between a and b that has that y coordinate. So let's take a look at some y over here. It's between f of a and f of b. Looking at the graph, we can see that indeed there is a point between a and b that has that y coordinate. Let's look at another point, maybe over here. Once again, there's a point on f of x between a and b that has that y coordinate. So let's take a look at an example to see how this can be applied. Show that p of x, which equals x cubed minus 3x squared minus 2x plus 5, has a root in the interval -1 to 2. Well, first let's see that this function is continuous between -1 and 2. It's a simple polynomial, so all the limits are equal to the function. So it is a continuous function. So we are allowed to use the intermediate value theorem. So let's first look at p of -1. When you do the math, you see that p of -1 equals 3. Now let's find p of 2. We see that p of 2 equals -3. Now we know that 0 is between 3 and -3. So using the intermediate value theorem, since 0 is between p of -1 and p of 2, we know that there must be some point with an x-coordinate between -1 and 2 that has a y-coordinate of 0. In other words, there's a point between x equals -1 and x equals 2 that is a root of this function.